So we have 3 interfacing to be studied, right? What are the 3 interfacing we need to study?
LCD, ADC, and which one with it now? That one.
Which is the third one? LCD, ADC, and the third one is stepper motor. Yes. So we have already covered LCD, and today we are going to study about ADC, and the next class we'll be studying stepper motor. Okay. Can you hear me?
Yes, ma'am.
Okay. Today we'll be studying ADC part, and the next class we'll be studying the stepper motor part. Okay.
Yeah.
So ADC, yeah, from here till here is LCD part. From here we'll be studying this. Can you see page number 324? From here we'll be studying for the ADC part. So how many of you have the textbook with you? Do you have the textbook that Muhammad Ali Masiri? Nobody is having it.
Textbook.
Okay, fine. I'll be sending the notes, right? You just follow that. Okay. So ADC, for the ADC conversion, there are certain steps to be followed. Okay. So can you see the screen? I'll make it a little more bigger. Okay. Certain steps to be followed. So the first step is make CS is equal to 0. CS is nothing but the time duration, clock cycle time duration. Okay. You'll be seeing it here. Clock source, right? Clock source. They have written the clock source in short form as CS. Okay. So the first step to be followed for ADC conversion is we have to make CS is equal to 0 and send a low to high pulse to pin WR to start the conversion. Yes. So what is the first thing to be done? We have to make the CS clock source to be lowered, and the next thing to be done is we have to send a low to high pulse to pin WR. We have to start the WR pin. We have to set the WR pin in high state. Initially it will be in the low state. We have to set it in the high state. Okay. So what are the 2 things to be done? Karishma?
First.
Karishma?
Ma'am, 1 second, ma'am. I'll close door.
Okay, what are the 2 steps, Mohan?
First, making CS is equal to 0 and send a low to high pulse to the right pin.
Okay, the 2 steps has to be done. The third thing to be done, we need to keep monitoring the interrupt pin. We need to keep monitoring the interrupt pin. If the interrupt pin is low, conversion is finished and we can go to the next step. Yes, if the interrupt pin is high, then we have to keep on monitoring till the interrupt pin goes low. Yes. Got it. The second point. So you know that when the interrupt pin is high, there is some subroutine program running, right? When the interrupt pin is high, then some subroutine program is running, correct? Yes. So what we need to do, we need to wait till the interrupt pin goes low. So when the interrupt pin goes low, that means that the subprogram which was running parallelly has executed successfully and now there is no interrupts. Yes. Yes. Can you able to hear me?
Yes, ma'am.
Okay, so what is it? What is the second step to be followed? We need to keep monitoring what?
Interrupt pin.
Why we have to keep monitoring the interrupt pin?
So that if there is an interrupt, then we should do that. Then if it is low, we can. That means conversation is finished.
Okay, so the second thing to be done is we have to keep monitoring the interrupt flag. Okay, till until it goes low. Then the third thing when the interrupt is low, when the interrupt has become low, we have to again make CS is equal to 0 and send a high to low pulse to RD. High to low pulse in the sense we need to give a command RD is equal to 0. Okay. We need to give a command RD is equal to 0 when the interrupt pin becomes low. Got it? So third thing to be done is when the interrupt pin is low, we need to make CS is equal to 0 and also we need to make RD pin is equal to 0. What is RD pin?
Read pin.
Read pin. So when the RD pin is kept 0, we can get the data out of ADC chip. Got it? So these are the three steps to be followed for the ADC conversion. So with the steps only, we are going to see the program further. So can you say the steps again? So somebody can say the steps. Manisha? Okay. The steps, we have seen the steps, right? So initially, so the steps only, they are just showing the steps in timing diagram. See, initially what we need to do, first we need to do is, see, we have to convert the CS pin to low, right? Mohan? First thing is we need to convert the CS. So initially maybe we are assuming that it is in the high state. So first, when we are planning to start the conversion, what we need to do, first thing we have to do is we have to make the CS pin to low. Okay, clock source pin to low. And the next thing we have to do is, okay, we need to start the conversion by writing a high pulse to WR, right? Yes. Can you see the mouse point?
Yes,
Can you see the mouse point? So we have to make CS is equal to 0 and at the same time we need to make WR is equal to high, correct? So that they are drawing as the timing diagram. See, CS is made as 0 and WR pin is made as high. Got it? Right bit is made as high. Okay. And the third thing is data. So data is allowed inside. So data is allowed inside. Okay. So the next step, according to the steps, the next thing we need to do is we need to keep monitoring the interrupt pin. We need to keep monitoring the interrupt pin till the interrupt goes low, correct? Yes, Mohan? Okay, so we need to keep monitoring the interrupt flag till it goes low. So this interrupt pin, initially it is high. We need to keep monitoring till the interrupt goes low. So start of the conversion, when this start of conversion happening, when is this start of conversion happening? When the right pin is kept high, the start of conversion happening. Because ADC, what is ADC? Analog to? What is ADC? Analog to digital conversion, right? So for making the analog to digital conversion, we have to write some input data inside, right? We have to write the analog data inside. So that is the reason when the right pin is high, the conversion is beginning. The conversion is beginning. Okay. And the interrupt will be kept in the same state because conversion is going on. Yes, the conversion is going on. So the subroutine program is running till the conversion is over. Understood? Can you see the diagram? Timing diagram?
Yes, ma'am.
Yes. So the conversion is happening from this point to this point. So the interrupt will be kept high. Yes. Got it. So what is the next step we have seen here? We have to keep monitoring the interrupt flag. If the interrupt is low, conversion is finished and we have to go to the next step. If the interrupt is high, we need to keep monitoring. Okay. Once the interrupt has become low, then what we need to do? We have to again make clock source is equal to 0 and then we need to make RD pin is equal to 0 to take the data outside, to take the converted data outside. Yes. So that is the reason after the when the conversion got over, we need to again make the CS pin, clock source pin is equal to 0, clock pin is lowered and we are reading it. We are making RD pin is equal to 0. Yes.
Yes, ma'am.
we are making the RD pin is equal to 0. Read that, that is nothing but read it. We are making the RD pin is equal to 0. When the RD pin is low, when we are reading it, the data is taken out. Yes.
Yes.
So this is the steps. And this clock source, see, there will be certain timing allocated for the clock source. That is the reason, see, initially we set it as low, and again after certain time it has gone high. Okay, so that is the reason at the end, again when we are taking the output back, we need to make it CS equal to 0 once again. Got it?
Yes, ma'am.
So these are the steps of converting analog to digital conversion. Steps for converting analog to digital data. Yes?
Yes.
So we will be seeing the program now. See, actually there are two type of ADC. The first type is 0804 and the second type is 0808. Okay, so but in our syllabus we have to study only 0804 type of ADC, and the pin diagram is given here. You just go through the pin diagram, which pin is connected to which port and all, you'll understand if you just go through the pin diagram. Okay, can you hear me? So we'll start the programming part. So what is the first step, Ra, to convert an analog to digital data?
CS is equal to 0.
What is equal to 0?
CS.
CS, right? The clock source is equal to 0. Okay, so before going to the steps of conversion, we need to initially set some basic arrangement, basic setting that is given here. Read pin is connected to bit 2.5. This basic arrangement is nothing but the pin diagram. You can see the pin diagram here, right? Can you see the pin diagram?
Yes, ma'am.
So in this pin diagram, see, read pin is connected to 2.5. So because we are going to use all these pins in the conversion process, so we need to first set which pin is connected in the which port is connected to which pin. Okay, so read pin is connected to port 2.5, correct? And you see the pin diagram, read pin is connected to port 2.5, write pin is connected to 2.6. The interrupt is connected to 2.7. So the same thing we have to initialize here. Read pin is connected to 2.5, write pin is connected to 2.6, interrupt is connected to 2.7. Yes.
Yes, ma'am.
Okay, this is initialization. Then the same way the data is given to port 1. So you can see in the pin diagram, data is given to port 1. Why we have directly given port 1? Because from P1.0 till P1.7, all the 8 bits are used for the data only, right?
Yes, ma'am.
So P1. P1.0, P1.1, P1.2, 1.3, 1.4 till 1.7, all things can be together called as
Port 1.
port 1. Yes. So all the ports are together used for what work? We are using all the ports together for what?
Data.
Data. So that is the reason here we are giving my data equal to port 1. And because here we are writing bit because it is port 2.5, we are only using one support of that location. We are only using one bit of 8-bit data. That is the reason here I am writing RD bit, WR bit. Got it? Are you getting it? Here I am using the whole 8-bit of data, right? For my data, I am using the location from 1.0 to 1.7. All 8-bit of data I am using. So that is the reason my data, I am not using bit here. Yes? because I'm using all the 8 bits of data. So now coming here, I'm making this port 1. I'm turning on the port so that the port accepts the input. I'm turning on the port. How to turn on the port? By giving the data, by giving a high pulse there, right? By giving a high pulse, by giving a high pulse, I'm turning on the port. Yes.
Yes, ma'am.
Okay. So here, then again, what I'm doing, set B INTR. I'm initially setting the interrupt. I'm initially setting the interrupt. Why? Because you can see the diagram. Initially, the interrupt is set high only, right? Can you see the
Yes, ma'am.
time? Initially, the interrupt is set high, so the interrupt is set high in the program also. Then initially, we are just clearing whatever, like why this clear WR has to be done. So if there is any previous data or anything is there, I'm just clearing it off. Okay, got it?
Hmm.
This all initial steps. Then from here, from the set BWR, I am going to start the steps which I studied before. Okay, and yeah, there is we have the first step, that is setting CS is equal to 0, right? Clock source is equal to 0. Yes.
Yes, ma'am.
The setting clock source is equal to 0, this thing will happen internally because that is a clock source. There is no need for the programmer to do it here. So we have to start from here. What is the first thing? We have to set a high pulse to WR. We have to set a high pulse to WR, right? So we are right. What is the first step here we need to do? We need to set a
High pulse.
high pulse to WR, right? So where I'm going to do it in the program, yes, starting from here is my program starts. Can you see the set to be WR? I'm setting the WR and I'm starting the conversion. I'm writing the data which I wanted to convert. So yes.
Yes, ma'am.
After that, what is the next step? You are remembering the step? What is the next step to be done? Step
Monitor
2.
the interrupt.
Monitor the interrupt. So here JB interrupt here. JB andre ಏನು? What is JB?
Jump borrow.
Jump borrow. Why I am writing jump borrow here?
If there is high, if there is a borrow,
high,
then it will
if there is a borrow,
it will go to here again.
It will be in the inside the same loop. Okay.
Hmm.
So we have how many bits of data here? How many bits of data we have? We have 8 bits of data, right? We are 8 bits of data. So we are allotting P 1.0 to 1.7. So till that 8 bits of data is transferring, it will be like lesser than 8. So borrow is there. Borrow, if we don't have only, then we'll be borrowing, right? So if it is lesser than 8, the borrow condition will be satisfied and it will be inside the same loop only. Okay, so if the 8 is satisfied, minimum bit, the 8 is satisfied, then there is no borrow. It will come out and go to next line. Yes. Okay, so the step 2 is right. Step 2 is what? We have to wait and check for the interrupt till the conversion gets over. Yes, we have to wait there to see the conversion is happening or not. Wait for the conversion. Then we'll see the timing diagram. What is the next step you're remembering? Are you remembering the next step?
Yes, ma'am.
What is the next step?
That
You can
is again CS is 0 and then put a low bit to read RD.
okay. So yes, here right pin, first pin I have made right is equal to high. Data is data transfer happening. Then I'm monitoring the interrupt. Yes, I'm monitoring the interrupt. And after that, once the interrupt is done, once the end of conversion, I need to make this read pin again low. As I said you, this clock source will be taken by internal command. So we no need to write it. Yes, so the read pin, we need to again lower the read pin. We need to lower the read pin again. Manisha? Manisha is there?
Yes, ma'am.
Everyone is sleeping or what? Nobody is responding. What you guys are doing there? where we are. So we have to clear the RD, right? We have to clear the read command. Can you see the step? We have to clear the RD command. Yes.
Yes, ma'am.
So the once RD command is cleared, the conversion has happened, and we can take the data out, right? We can take the data out. Yes. So the data is there, and the data is stored in the port. Yes, and the port is connected to my data. I'm taking the data. So actually, till here is only the steps for the conversion of A to D, analog to digital conversion ends here. The clear RD is there, right? In that the conversion ends. We are taking the
Yes, ma'am.
output. After this, they have written few lines is because I'll say you because we need to display the data, right? So in order to display the data, we need to convert the data from hex to ASCII conversion. Yes. See, examine the ADC 80804 for connection to 8051 in figure 13.4. The following program monitors. What they're saying, the following program which we are studying is monitoring the interrupt pin and allows an input to register A, and that input has to be again converted to hex, converted from hex to ASCII to display the output. Got it?
Yes. Yes,
So
ma'am.
the data is already converted from analog to digital in this line clear RD itself. Now, in order to display the data, we are writing the further steps. Okay, so what are the further steps? My data is moved to accumulator. Yes. After moving to accumulator, I am calling the subroutine A call conversion, and it is not given. How it is converting all these things is not given. So A call conversion and it converts hex data to ASCII. In order to display it, the ASCII conversion is necessary. Okay. So after that, they are calling the display line. So the data is displayed in the screen. Yes. Hello. The voice is not clear.
Voice is clear, ma'am. I
Then
think you
why
can hear what I am telling, ma'am.
I can hear only you. I cannot hear anybody else. Okay. So once the data is converted and it has been displayed, and after that, again we have to make RD is equal to 1 for the next round. For the next round. Okay. So we have taken the data out by clearing RD. Again, if I want to convert, I need to set RD again. And again, I have to go to STM back and write the next data and convert. Understood?
Yes, ma'am.
Okay, now this is assembly language program. The same thing we can see in C language also. Yes, same steps. Actually, that is not there in your syllabus. There is no need to study, but you just go through. Like it's better to just know how to write it in C language also. So, what is that initial step? We have to include the header file for C language.
Yes, ma'am.
And what are the initial steps we need to do? How many lines? 1, 2, 3, 4, 5 initial steps we have, right? 5 initial steps. What is first? Allocating bit to RD, all these things. This all 5 initial steps is also done here. S bit RD is equal to 2.5, port 2.5. S bit WR is equal to port 2.6. Yes. In C language, the supports has to be written by this symbol. And I'm allocating all the things. And what is SFR? What is the full form of SFR? Special function register. Okay, so because I'm taking the whole data and the port location is allocated to special function register, so that is what it is written there. That is nothing but here my data EQ1 is EQ is equal to port 1, right? That is also done. My data special function register. Then after that, all initial things is done. Void main unsigned character value. I'm taking the data and I'm what I'm doing here. First I'm making port 1 is equal to high, right? I'm making port 1 is equal to high. Yes. Same way here also, to make port 1 is equal to high in C language, I have to make my data is equal to 0xFF. Then what is the next step I'm doing here? I'm setting the integer, set to be integer. Yes, next line. Same way here also, I'm setting the integer. I'm setting the integer is equal to 1. After that, RD is made high. RD is equal to high. Here also I need to make set to be RD. I need to make set to be RD. Okay. Then the same steps is followed in C language. What is the next? Clearing right, set to be right, and all those things. Here also I have to follow. Right is equal to clearing right, then set to be right, then monitoring the interrupt flag, till the conversion happens, then taking the data out by giving RD is equal to 0. Then this conversion, I need to take the output and give it to some location, some place for the conversion, right? That thing happening here. Convert and display, and again RD is equal to 1 to start the next cycle. Understood? Okay, that is the end of this analog to digital conversion topic. Okay.